typically whole numbers. 0, 1, 2, 3, 4, 5, 6. We don't normally have negative exponents. That's because when it's written in standard form, let's talk about it really quick. If I want to say, I'm just going to write this. You guys do not have to write this. If I'm going to say 3 to the negative second, that means I'm multiplying 3 by itself negative 2 times. So what's wrong with that sentence? What's weird about it? That's okay. I'm going to get y'all thinking this morning. Haley, can I talk to you? Actually, it might be more fun to talk to Sean. I'm going to pick on Sean. Hey, Sean.
Yeah.
Hey. All right. If your mama woke you up this morning and said, Sean, go brush your teeth negative 2 times because your breath stinks. Does that make sense?
No.
No. All right. Who up here plays sports? Jordan, you play basketball, right?
Yes, ma'am.
All right, Jordan, if you're missing your free throws at practice and it's just, that's a no-no. I played basketball too. That's a no-no. You got to make your free throws. If you're missing your free throws and coach just gets pissed off at you and he's like, all right, Jordan, go do negative 2 suicides. Do we know what that means?
No.
No. So in the real world, in life, we don't have negative time. So if I'm telling you to multiply 3 by itself negative 2 times, that does not make sense. If I told Sean to go run around the track negative 2 laps, that doesn't make sense. It doesn't mean go backwards either. Like, we don't know what that means. So typically, exponents are not negative. They're whole numbers. 0, 1, 2, 3, 4, 5. They've got to be positive, okay? That's what you guys are used to seeing. Does that make sense?
Yes.
Okay, good. Okay, so what we're going to learn in math 2, I'm looking for my blue pen. I lost it. What we're going to learn in math 2 is that typically they're whole numbers, but they also can be rational, which means ratios. So, oh, it's not working. There we go. We can have any rational exponent. So can somebody give me an example of a rational exponent that is not a whole number?
Square root of 36.
Okay, good. What's the square root of 36, everybody?
6.
6, which is a whole number. So give me an example that doesn't make a whole.
7.3 repeating.
Okay, 7.3 repeating, which would be 7 1/3. I told y'all I'm going to get you used to switching these decimals to fractions. 0.3 repeating is a third. So 7 1/3 as an improper fraction. Remember, we talked about this last week. 3 times 7 is 21, plus 1 is 22. So 22 thirds. You can actually have 22 thirds as an exponent. It's not negative, so we can visualize what that is. It's 7 1/3. So you can have, in math 2, we're going to get to this next week, but I can actually have x raised to the 22nd thirds. We're not going to worry about that today. We're just going to stick with whole numbers today. But I do want you to know that we are going to get into rational exponents next week, where our exponents are ratios. Okay? Y'all are so quiet. Is my handwriting okay? It hasn't gotten crazy yet?
It's bad. It's really bad.
Who said it's bad? Is that Sean? It was. Sean, you forgot right after you talked, your box is still lit up. It's not that bad. I've seen worse. I've also seen better though. Some of y'all have great handwriting. All right, there are 6 properties of exponents. So what I was planning on doing is talking about all 6 properties, and then we can do examples. Do y'all need to see examples as we go, or are you okay with saving them till the end? because I can do it either way. So do you guys want to do a property and then an example of that property each time? Or do you want to do all the properties and then do all the examples at the end?
I would rather
At
do
the end.
examples as we go.
As we go, yeah.
Okay, I heard both. Why don't we do a little bit of both then? So we'll do one as we go, and then at the end I'll have like 3 to 5 for you to try. Does that sound good?
Yes.
Okay, let's do that. All right, so the first property is your product of powers property. If I'm going too fast for you guys writing, just let me know and I can slow down. Or if I'm going too slow, let me know. Evan, I also got your chat earlier and you got your extra credit point. All right, so let's talk about this first property. What is a product? I had some of you ask me good questions about this yesterday. What's a product? Ooh, y'all are hurting my heart. What's the word product mean in math?
The answer to a multiplication problem.
Good. It means we're multiplying. The product of something is the answer when you have a multiplication problem. Very good, Carter. Extra credit. Good job, Evan. So a product means we are multiplying. Does everybody understand that? So what this first property is talking about is what you do with powers, which we know a power is just
Exponent.
thank you. There we go. We know a power is an exponent. So we're going to talk about in this property what we do with exponents when we're multiplying, okay? So when you're multiplying 2 or more terms, with that W slash just as an abbreviation for with. I use a lot of shorthand because math can be a lot of writing. With like bases, who remembers from middle school or math 1, or actually you guys do this in 7th grade, believe it or not. Who remembers what we do with our exponents when we're multiplying 2 terms?
Add them together.
Good, Carter. You're going to add the exponents. So I think most of us have seen this, I hope, but I'm not sure that anybody ever showed y'all why it worked. So I am going to show you why it works. We'll do an example. We'll move on to the next one, okay? I do want y'all to underline exponents. I did not say add the coefficients. I did not say add the bases. What are we only adding?
The exponents.
Good. These are exponent properties. Don't you go adding my coefficients out front, okay? All right. So we'll do just a basic example so I can show y'all why this works. And then we'll actually try one. All right, if I have 2x to the 3rd times 3x to the 5th, and we're multiplying, the first thing I need y'all to understand, this says if you cover up the letters, 2 times 3, right? Yes, no, I gotta make sure y'all are with me.
Yes.
Okay, if it's too fast or slow, y'all gotta let me know. Y'all gotta talk to me. So if you cover up the x's, this just says 2 times 3. You are not adding the 2 and the 3. Those are coefficients. So you gotta do whatever operation the sign tells you to do. So what is 2 times 3?
6.
All right, so we know our coefficient is gonna be a 6. Now, we wanna figure out how many x's we'll have if we'll multiply these 2 terms, right? So I'm hoping in middle school you were shown this, but I'm not sure. X to the third means I'm multiplying X by itself how many times?
3.
3. So this basically means I have 3 X's, right? So X to the fifth means I'm multiplying X by itself how many times?
5.
5. So you have 5 X's. So if I'm putting all these X's together, because multiplication puts terms together, how many would there be?
8.
8.
Good. So that's why we can add the exponents, because if you expand the X's and write out how many there are, you're actually just finding the total. So this would just be X to the 8th. Did y'all's middle school teacher show you that?
I
Yeah.
think so.
Okay, good, good. So this, I'm not gonna lie to you, this is a basic middle school math 1 problem. We're gonna see something a little trickier in math 2. So can I add on?
Yes.
Okay, and then we'll go to the next one. So here's a little bit trickier example. Let's do, all right, so what am I doing with these 2 terms, these 2 expressions? What operation?
Multiplication.
Multiplying.
Multiplication, good. So what that means, I need to multiply my coefficients, but then I'm gonna match up my bases, put X's with X's, Y's with Y's, and what am I gonna do with the exponents?
Add them.
Good. So I don't want y'all to freak out that there's negatives. It's not gonna affect anything right here. So we're gonna multiply our coefficients. So what would my product coefficient be?
-28.
-28.
Very good job. -28. -4 times 7 is -28. How many X's am I going to have in the product?
It's 4.
Good. How'd you get 4?
Because 6 plus -2, you take away 2 because it's a negative, so it gives you 4.
Very good. So you add the exponents, and notice how she put X's with X's, okay? We're not mixing. So like bases, these 2 things go together. You're combining like terms, basically. And then how many Y's will I have in the product?
6.
Okay, good. So y'all can do product property, right?
Yes.
Okay, great. All right, if y'all are good with this, and we'll move on to the next property. Is everybody good?
Yes.
All right, let's flip it. Anybody has a question, unmute and ask. I know this is boring. Notes won't always be this long, and they won't always be done this way. Sometimes I use PowerPoints and stuff too. But I have to see how much you guys learned when y'all were virtual last year. All right, so the next one we have is the quotient of powers property. All right, so similar to what I asked you guys before, what is a quotient? What does the word quotient tell you guys we're doing?
The answer to a
Dividing.
division problem.
Very good. It's the answer to a division problem. It means we're dividing, right? So when you are dividing, terms with like bases, who remembers from Math 1 what we do?
Subtract.
Very good. So this is the way I used to remember it. When we're multiplying, we're putting the things together, right? So you're going to add. Division is the opposite, the inverse operation of multiplication. So when we're multiplying, if we add, then when we divide, we're going to have to subtract. And here's why. When you're dividing terms, you're splitting them apart. You're breaking it up into groups. So we're ending up splitting it or taking it away. So when dividing terms with like bases, you are going to subtract. Now, this is where you might have learned something different. Some teachers teach you to always do numerator minus denominator. I don't do it that way because I don't like having to deal with negative exponents. So what I teach my kids, if there's a couple of you that had me for Math 1, what I teach my kids in Math 1 and then in 8th grade too, when I tutor 8th grade math, is to subtract the bigger exponent minus the smaller one, because then you won't have any negatives, okay? So I'm gonna write that down. You don't have to do it this way though, so I'll show you both ways. When dividing terms with like bases, subtract the exponents. There's two options you can do here. Do y'all want me to write them both, or do you want me to write the way I do it and then just show you both?
Show the way that you do it.
Okay, we'll do the way I do it. So we're gonna subtract the big one minus the small one. Bigger exponent, take away smaller one. So you're gonna subtract the exponents, and then your answer is gonna end up wherever the bigger exponent came from. A lot of you guys, when we took the personality test, were green, which means usually you're auditory. So that's why I'm writing out the words. I'll make sure my green people get what they need. My blue people and my golds, and honestly oranges too, y'all usually need to see like visual examples and pictures. So we'll do both. All right, so here's our first example. All right, so do you guys agree in this example that it's a quotient?
Yes.
Okay, so we're dividing our two terms, right? So when you're dividing, you are not subtracting 8 take away 12. Does everybody understand that? Those are not exponents. What are the 8 and the 12 again? What do we call those?
Coefficients.
Coefficients, very good. So what do I do with my coefficients?
Simplify.
Divide them, and I really like whoever said simplify. 8 does not go into 12 nicely, right? We know it's going to be a decimal. So instead of doing 8 divided by 12, somebody said simplify. 8/12 is a fraction. So what does 8 over 12 reduce to?
1.5.
Close.
2/3.
2/3. How'd you get 2/3? And who is this so I can get your extra credit?
Soraya.
Raya. Good job, babe. She's killing it.
Because you can divide both of them by 4. So 8 divided by 4 equals 2. And then 12 divided by 4 gives you 3.
Girl, I couldn't have said it better myself. Good job, babe. So that is 2/3. So her explanation makes sense to everybody?
Yes.
The greatest common factor, I hope that word rings a bell, between these two numbers is 4. So if you divide them both by 4, you get 2/3. Very good. Now, take a look at your A's. In middle school, this is where if you learned, I'm going to do it the other way over here, because this is how a lot of middle school teachers and some teachers outside Central teach it this way too. they'll teach you to always do numerator, subtract, denominator. So what happens if we do 3 take away 7?
-10.
-4.
-4, good. So just watch. You can't leave it like that. We're going to learn in a second what you should do with that. And I think some of you may already know. But you can't have a negative exponent because we already talked about we don't know what it means if I say a times itself -4 times. So this is why I don't typically do numerator minus denominator, because you will a lot of times get a negative and then it creates an extra step. So what I do is subtract the bigger one minus the smaller one. So where are my A's bigger, in the numerator or the denominator?
Denominator.
Good, in the denominator. So 7 A's is greater than 3. So if I do 7 minus 3, I'm going to get
4
4. And then where were they bigger?
on the denominator.
Good. So the 4 A's are going to be left in the denominator. And that would just be your answer. 2 over 3A to the 4th. So I think they showed you this in middle school, but just in case they didn't, if I have A to the 3rd, we said that's A times itself 3 times. A to the 7th is A times itself 7 times. And you guys don't have to write this unless you want to. I'm just showing you because this isn't how we do it in high school. Our problems get way more complicated than this. So when you're dividing, what happens when you have a term divided by itself? Oh, y'all, what's 2 divided by 2?
1.
Good. So they cancel because you're dividing it by itself, right? It just becomes 1. So this is going to become 1. This is going to become 1. This is going to become 1. So I'm left with 4 A's in the denominator, which is what we got when we subtracted. Does this make sense?
Yes.
Okay, I'm not going to lie, y'all. This is the one my kids mess up on a lot, which is why I'm spending a lot of time on it. Are there any questions before I make it harder?
No.
All right, let's do it then. So let's do 16. I'm gonna use some different letters so y'all don't get used to seeing the same thing. 16 W to the 2nd, Y to the 9th, and that is a Z. So anytime I do a Z, y'all will see me put a line through it because my Z's and my 2's kind of look the same. And then all right, let's do this division. Okay, so where do you guys want to start?
The coefficients.
Okay, good. You don't have to start with the coefficients. I typically do just because I go from left to right because ADHD is real, y'all. And if I don't, I'll leave something out. So let's do the coefficients first. That's fine. 16 divided by 4. Remember, you're not subtracting. You're dividing the coefficients. So what's 16 divided by 4?
4.
It's a whole 4. So where do we put the 4 if it's a whole number?
At top.
Good. And the numerator. Good. Was that Jordan?
Yeah.
I think it was. Good job, Jordan. I got to make sure. I got to get you extra credit point. Good job, babe. In the numerator. So 4 is going to go in the numerator. Now, I'm looking at my exponents, and I noticed some of the ones in the top in the numerator are smaller, which means I'm probably going to be left with a denominator. I'm going to go ahead and draw my division bar. Does anybody know what this is called? A division bar? There's a fancy name for it. I'll tell you what, first person to look it up and give us the answer later will get 2 points extra credit. There's a fancy name for a division bar.
What's the question?
What the fancy name for a division bar is. I don't want you looking it up right now. If you blurt it out to me now because you Googled it, then that's not good because we're going to finish doing the example. But look it up later, send it to me in an email or a text message, and I'll give y'all extra credit, okay? All right, where are my W's larger?
The denominator.
The denominator. So Carter, do you agree they're going to remain in the denominator after I subtract? That's where they'll be left?
Yes.
Okay, so Carter, what's 3 take away 2?
1.
Good. Now, this is where you'll also hear different things. Some teachers will tell you not to put the 1. You can put the 1. It is still in simplest form if you put the 1, because even if I don't write the 1 and I just put a W, we know the exponent is an understood what?
1.
1. Good. So it doesn't matter. I write it because I'm visual and I need to see it there. You don't have to, though. You can just put W. What about my Y's? Where are they going to be left and how many will there be?
Numerator
Be
Numerator. And how many?
5.
5.
Good. So Y to the 5th. Please don't say Y5. That makes me think we're playing bingo. Y to the 5th. Or you can say Y to the power of 5. Okay? And then what about the Z's? This is where y'all will mess up.
Denominator
And how many?
7.
Good. That's where people mess up. They'll just copy over 8 because this one doesn't have an exponent. Remember, if it's not written, what did we just say it is? It understood what?
1.
Good job. So you can write it if you want to, if that helps you.
Is it 7 or 9?
Oh, I'm sorry. She said 7. Thank you, Haley. She said 7. Just Lord, I don't know why I wrote 9. Because I'm crazy. Are you guys okay with the quotient property?
Yes, ma'am.
Okay, I think we're just going to do 2 more today because I don't want to spend a whole bunch of time doing stuff that y'all may not need. If that's cool with y'all. Are y'all okay if I just do 2 more today and we'll do the other 2 tomorrow?
Yeah.
Okay.
Yeah.
All right, so we're done with that one. Ooh, I don't know, we might need to do 3 more. We'll see. I know I can save 1 for tomorrow. I think y'all might need another one. All right, next one. Like I said, this is the most notes you will have to write this unit. Just because there's so many properties. Power of a power property. So what the power of a power property says is when you have one power raised to another power, that you have to carry in the outside exponent. You distribute it in. So we're going to write that. When you have one power raised to another power, I don't want to write distribute. When we distribute, guys, what operation are we doing? You guys know what distributing is, right?
Dividing.
Multiplying?
Good. You would multiply. You guys have seen this before, right? Where you carry the number on the outside, inside. That's called distributing.
Yeah.
Okay.
Yes.
Good. I was worried y'all weren't answering. So that would be 2x plus 6, right? Okay, so when you have one power raised to another power, you're going to carry in the outside exponent, which means we're going to be multiplying it. So let's write multiply every exponent inside the parentheses by the outside exponent. honestly, y'all, we probably just need one example for this one, if that's okay with everybody. All right, so one more time, when we have one power raised to another, we're going to distribute in the outside exponent, which means we're going to multiply every exponent inside the parentheses by the outside one. So y'all talk to me a little bit. What are my exponents that are inside of the parentheses?
2, 4, and 1.
Good. Are there any others?
Oh, wait,
Is-
1.
Is
Good.
there a 1 on the 2?
Yes, there is. So that's where y'all will mess up, is you guys won't carry the 3 to the coefficient of 2. So remember that 2 has an understood 1 and so does the z. So what I'm going to do is I'm going to distribute in this third power. So this exponent of 3 goes into all the other exponents. So there's 4 of them. And then you're going to multiply the exponents because you're distributing. So what am I going to get in this next step? If I multiply my exponents.
2 to the power of 3.
Good. 2 to the power of 3 or 2 to the third.
X6.
X to the 6th. Good.
Y to the 12th.
Very good. Y to the 12th. And
C to the 3rd.
very good. So there's your power of a power property. Now here's the tricky thing with power of a power. Sometimes you'll have to simplify. So there's one term in this expression that I see that can be simplified. What do y'all think?
Coefficient.
Good, the coefficient, 2 to the 3rd. So who can tell us what 2 to the 3rd power is? 2 times 2 times 2, what is that?
8.
Oh, good, yes. I was hoping nobody would say 6. It's not 6, you're not doing 2 times 3. It's 2 times itself 3 times. Do you guys feel like you could do power of a power property?
Yes. Yes.
Okay, are y'all okay if I go ahead to the next property then?
Yes.
All right. We'll do one more today, and then I want to show y'all an extra example or two at the end. So the last one we'll do today, and we'll pick up on this same page tomorrow, is your negative power property. So what do you guys think this one is going to be dealing with?
Negatives.
Negative what?
Exponents.
Good, negative exponents, negative powers, okay? We kind of already talked about this. If I told Sean to go brush his teeth -2 times, that doesn't make sense. So when you have a negative exponent, there's something you have to do to it to turn it positive. Does anybody remember what we do from middle school?
Aren't you gonna like move it to the bottom or something?
Oh, yeah. Okay, not necessarily the bottom, though. You move it to the opposite side, the other side of the division bar. So if it was in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. Good job, Jordan. You're killing the game. All right, so when you have, or when you raise a term to a negative exponent, you must move the term to the opposite side of the division bar. to turn the exponent positive. I know that was long, y'all. This is our last one we're doing today. We'll do an example or two, and then you guys are going to do one more with me at the end to make sure we're good on the homework. I would definitely recommend, since we're virtual, I don't need to tell y'all this because you're already up here, but tell your friends that aren't up here. It's going to be way easier if you join live and do the notes live with me so you can ask questions. And then I will still do office hours Zoom every day too. So if there's problems on the homework that you need help with, like maybe you missed them the first time in Delta Math or something and you just want to work it out with me, just hop on office hours. They are at a different time today and tomorrow. I have meetings after school on Tuesdays and Wednesdays. So instead of starting at 3, they'll start at 4, okay? All right, so if we raise a term to a negative exponent, you move the term to the opposite side of the division bar to turn the exponent positive. So I'm going to give y'all 2 just quick examples for this one. So let's say we have C to the negative. So 5b to the negative 4th c over c to the negative 5th. All right, there's a couple different ways you could go about doing this one. I'll show y'all both ways if that's okay. That way you can choose what works best for you. Does everybody agree this is a quotient that we're dividing?
Yes.
Okay, so there's no other coefficients. So we know that 5 is going to stay in the numerator, right?
Yes.
So what we need to try to simplify are our variables, the b's and the c's. Are there any other b's to put with this one?
No.
No, but this says b to the negative 4th. So this would be like riding your bike negative 4 times. You can't do that. So what our rule tells us is if there's a negative exponent and there's nothing to combine with it, you're going to move the term. So I'm going to move b to the negative 4th to the other side of the division bar, and then it will turn positive, the exponent. So does everybody agree I can write that as b to the positive 4th in the denominator?
Yes.
That's all it's telling you to do. So then there's a couple different ways you could do your C's. The first way you could do your C's is there's 2 of them, right? In the numerator, this is C to the 1st. So instead of having to move your negative, what do we do when we're dividing with our exponents? Oh,
Add.
not add, when we're dividing?
Oh. Subtract.
There we go. Is everybody with her? That took y'all a while. Division, you're going to subtract. So if you do the bigger exponent minus the smaller one, which one of these is larger?
1.
1. So you could do 1 minus a negative 5. So let's talk about it, guys. What happens when you have minus a negative?
Plus the positive.
Good, it turns positive, right? So 1 minus a negative 5 is really going to be c to the what?
Power 6.
Good job, Henry. C to the 6th. And then does everybody agree with Henry? It would be in the numerator.
Yes.
Because that's where the larger one was. Haley, are y'all with me? Are y'all okay with that?
Yes, ma'am.
Okay. So you can do your subtraction, and a lot of times it'll get rid of the negative. That's the first way you could do this one. The second way you could do it, and this is typically the way I do it because I'm going to be honest with y'all, I'm not good at stuff like this. Like if I'm going really fast, I'll be careless and forget to add there. So what I do is I see, okay, C is to the negative 5th, which means I would move it because I can't have a negative exponent. So when I move it to the other side, to the top, it would become a positive 5, right? So then,
Yes.
good. So then if I have 1C and I'm putting 5 more with it, that would end up being 6. I don't care which way you can do it. You can subtract here, or you can just move the negative and then put them together. But either way, does everybody agree we get 5C to the 6th, B to the 4th?
Yes.
Okay, cool.
Yes.
Do y'all need another example, or do you think you're good?
I'm good.
Okay. Anybody want another negative example? All right, I'm not hearing yeses. So before y'all leave, I do want us to look at one like this together. This is just an extra example that'll help you on your homework. So what I'm about to give y'all is one where it combines a couple of the different properties, okay? Just so we can talk about what we do with them. We'll do more of these tomorrow. All right. Does everybody have it written down, or we're getting it written down? Y'all are so quiet. Yes, no?
Yes.
Okay,
I just finished writing it down.
you're fine. Y'all just, I feel like y'all are afraid to unmute. I'm ADHD, y'all have to talk to me or I get bored. All right? I'm also very nice, so please talk. This looks a little confusing, right?
Sure.
Sure. Who said sure? I feel like that was Sean being sassy. Sure. So we're dividing and then we're raising to a power of 2, right? Okay, so this is one where in middle school, again, you can do this one different ways. Now, I do it one way over the other because it ends up being less steps and less to look at. And for most of us, I feel like it's the best option. The first way, a lot of teachers teach to go ahead and take the exponent of 2 into everything on the inside. I don't teach it that way because that's going to get really crazy. You're taking 2 in and you're multiplying it by 8 different things. So that's going to get very large very fast, right?
Yeah.
Okay, so what I do, I follow PEMDAS. We all know what PEMDAS is, I hope.
Yes.
Yes.
Okay, please excuse my dear Aunt Sally. Is that what y'all learned?
Yeah.
Okay. I teach my math 1 kids a rap now. It's really fun. If you want me to rap for you later, I can. But the P stands for parentheses. So I always do what's on the inside first. So do the parentheses first. Try to make it as small as you can. And then we'll worry about the exponent of 2 on the outside. So let's reduce the inside first. So on the inside, does everybody agree we're dividing?
Yes.
Yes.
Okay, so when we're dividing, guys, what are we going to do with our coefficients?
Simplify.
Simplify.
Simplify, very good. And what are we going to do with our exponents?
Subtract.
Look at y'all, very good. Henry, you're getting all the extra credit, babe. Good job. So simplify the fraction, the coefficients. What is 2 over 6 reduced to?
1/3.
1/3.
Very good. So I'm going to bring down 1/3. And now let's go try to simplify our variables and exponents. So I'm going to put the x's together, x's with x's. There's 2 x's in the denominator. How many are in the numerator?
1.
1.
Good. All right, so let's talk about it. If I subtract those, the fastest, easiest way, so there's less steps, do the bigger one minus the smaller one, and then the x's will be left where the bigger one was. So does everybody agree 2 is bigger than 1?
Yes.
Yes.
Take away 1 is
1.
1x in the denominator. And I'm going to put the just because I'm visual. Are y'all okay with that?
Mm-hmm.
Okay, where are your y's bigger?
In the numerator.
Numerator, good, Haley. So there's 3 in the numerator. How many are in the denominator?
1,
Okay, so 3 take away 1 is
2,
2. And where are these gonna go?
numerator.
Good. So y squared. All right, let's look at these z's. One's positive, one's negative. Do you guys want to subtract them, or do you guys want to just move the negative and put them together?
Move the negative.
Yeah, that's the way I typically do it. Again, you can subtract if you want. I'm just not great with subtracting negatives in my head, to be honest. So I'm going to move this one, z to the negative second. If I move it to the other side, then it'll be positive, right?
Mm-hmm.
Okay, so now I've got z to the 4th with z to the 2nd. So how many z's is that?
2.
6. Good. So this looks a lot better than what we had, and we're raising it to a power of 2. Does anybody have questions? All right, what do I do with this power of 2 now? Anybody?
You would
Multiply it to all the numbers.
outside of
Distribute to each one.
Oh my God, good. Like 5 of y'all started talking at once. Good. I heard all of you though. So I heard multiply it in. I heard distribute it to every exponent. I heard multiply it into every exponent. Those all mean the same thing. Good job. So this 2 goes into every exponent. I need you to remember it also goes to the numbers because they have an understood exponent of what?
1.
Good. Very good. That was Sean, right? So you can get your extra credit. Thank you. Yeah? Okay. So this would be, does everybody agree, 1 squared? If you take,
Yes.
okay, sorry, my handwriting's getting a little crazy. 1 squared. How many y's will I have now if I take this 2 in?
4.
Good, 4, y to the 4th. How many z's will I have?
12.
12, good. So remember, look at your z's. 6 times 2 is 12. Z to the 12th over 3 squared x squared.
Mhm.
Okay. And then what can we simplify for our last step?
Coefficients.